remind you that at some point in time between elementary school and middle school, you were finding area of a triangle all the time and were always correct, right? And that's because your teacher was giving you nice, pretty triangles that were right triangles. Okay? And then one day she got evil and she tried to torture you, and so she gave you a triangle that looked like this. What's the problem? No right angle. So you have to find the altitude of the triangle, form that 90 degrees, so this will be your base, and this will be your height. Everybody with me? Now, some of you got that concept, but when you start doing it, you didn't know, well, does that find the area of just this piece? Oh, wait a minute. Maybe if this base was 20, that I can say that it's 10 and 10. Okay, I don't care. We don't care that it's equal or not, because look on this one here. Is this base cut in half for each part? So this altitude does not mean that that piece down here at the bottom, the base, is cut in half. Don't try and change it that way. You don't know unless they tell you other information. Okay? But when I use the base, and when I do the height, right, it finds the area of this entire triangle, the whole thing. You don't have to work it twice because you can visually find two triangles. Are we okay with that? So when you came in, you got a formula chart. Somebody tell me on the formula chart, what's the formula for area of a triangle? Good. Base times height divided by 2. Some of you would rather use it as 1/2 base times height, but both of those formulas are exactly the same. Okay, I'm going to give you a second, and I want you to find the example. I'm going to give you a second. I want you to do the example on your own. We have a triangle. Good. Area equals base times height divided by 2. What did I tell you to find every single time? A right angle. So does the example have a right angle?
Yeah.
Yes, it's right here. And what are the two sides that touch it? This one and this one. So those are the two sides you use to find the area. What are they, 24 and 28? So 24 times 28 divided by 2. What did you get? 336 what? Meters squared. It is not 336 squared. 336 times 336 is not 336, right? So it is not 336 squared, it is the meters that are squared. That's what tells you we're talking about the area. Like how much wood does it take to cover the desk? How much wrapping paper do you need to wrap this present? Those are area things. Okay? Ooh, look at number 1. What shape is that? Do we really care? No. What did I tell you we had to find in order to find area of shapes? 90 degrees. Do you see some 90 degrees? Good. So let's focus on that. Don't focus on what the shape actually is. Focus on that I can find 90 degrees. And I bet the first one y'all looked at was this one over here. Is that true? I'm going to use the two sides that touch that 90 degrees. That would be the 16 and the 21. Well, what happens if I connected that? What shape would I have? Oh, a triangle. How do I find the area of that triangle? Good. Area equals base times height divided by 2. I'm going to use the two sides that touch that 90 degrees. So it's going to be 16 times 21 divided by 2. What do you get? 168 what? Is it meters?
No, we don't know.
Oh, so what do we use if we don't know?
Nothing, just square.
Units. Units is what we know. Units is what we use when we don't know. So that's going to be unit squared. Does that answer the whole question?
Oh, yeah.
No, that just tells me this little green triangle right here. Do I have another right angle?
Yeah.
Uh-huh. So if I have this other right angle, that would be this side here and this side here. What shape does it make? Oh, a triangle. So it's still base times height divided by 2. I'm going to use the two sides that touch that 90 degrees. So that would be 33 times 20 divided by 2, which would be 330 units squared. Oops, I forgot my square right here. Now what? Add them together because I want both the red triangle right? And the green triangle. So when I add them together, I get what? 498 what? Units squared. Okay, I'm going to give you a second, and I want you to try number 2 and number 3. Sometimes if you break it down too small, then you have all these little pieces, and what happens is you get it wrong because you leave a piece out. So be cautious. I could absolutely go and find the area of each little bitty triangle and add them all up. But I have to remember to do all 4 of them, correct? But I told you all you had to find was 90 degrees. So right here I have a 90 degrees right here, don't I? Yeah. And the 2 sides that touch it would be this one and this one. Would that be true? What shape does that make? So if I use this long base, the whole one, and this, that finds the area of this big triangle right here, doesn't it? Are you with me? Okay, so the area equals 40 times 56 divided by 2. And what would I get? 1,120 units squared. Very good. Okay, and then if that's 90 right there, wouldn't it be 90 on the other side? So then I could have this base and this height. So then it would be 40 times 26 divided by 2, which would be 520 units squared. Now, I could have gone back and done each individual triangle and added them up. That would have been okay, but wasn't this a lot quicker? Yeah. Okay, but you have to make sure you understand. I don't really care which way you use. Okay, but then I would need to add them together. So that would give me what? 1,017? Is that right? Oh, I'm on the wrong problem. I'm sorry. In my brain, I was on the wrong problem. 1640. Yes. Sorry. My brain skipped a couple problems. I'm sorry. Are we okay? All right. Ew, what's wrong with number 3?
A lot of things.
A lot of things, because when I look at it, you and I can see different stuff. You see like 6 different triangles, don't you? Good. What did I tell you to look for? 90 degrees. Don't worry about what the shape is. Don't worry about trying to figure it out. I want you to find the 90 degrees, and I bet most of you looked at this 90 degrees first. What are the 2 sides that touch that 90 degrees? This one and this one right here, doesn't it? So what shape do I have? A triangle. Okay, does that help narrow down to what this shape should look like? Yes, because then I'm going to do 54 times, is that a 21? Divided by 2? And that gives me what? 567 units squared. And then I have another 90 degrees right here, don't I? And I have a base and a height right here. Isn't that another triangle? So now that one's going to be 60 times 15 divided by 2. 450 units squared. Now what? Good, I'm going to add those together and I get what? Now you'll know where my brain was, right? Units squared. 1,017 units squared. Okay, I'm going to give you just a second. I want you to look at number 4. I want you to try number 4. Any ideas?
Multiply it by 2.
What? What do you mean multiply? Wait. But how do I know what to do and how to set it up? Write the formula. What's the formula? Y'all are so smart. You're my only class that said that today. The rest of them told me that it was base times height divided by 2. Is that a formula? No, a formula has an equal sign on it. So that's going to equal to what? The area. Area equals base times height divided by 2, which you are absolutely right. It told me right here that the area is 72. So I'm going to cross out the A and I'm going to put a 72 there. How many of you did that? Good. And that's going to equal to base times height divided by 2. Oh, wait a minute. It told me right here that my height is 8. So this number right here is 8, right? Now what? Divide by 2? This says divide by 2. What's the opposite of divide by 2? Very good. So I'm going to multiply both sides by 2. And then this cancels out. What's 72 times 2? 144 is equal to b times 8, right? Now what? I want just b, don't I?
Divided by 8.
Divide by 8. Excellent. So b is equal to what?
18.
18. Excellent. Okay, try the last one down there. Be careful, I'm tricking you again. What question are they asking?
Find the area.
Find the area. If you're one that always misses what the actual question is asking, then over here you need to tell me the formula. What's the formula? Good. I write it over here to make sure that I don't forget to plug it in there. I know that's what they're asking. That's what I need to find. But I have to first make sure that I have the information that's needed, don't I?
Mm-hmm.
So what did you do next? We drew a triangle. What kind of triangle?
A right triangle.
Good. Now what?
And then you divide it by 3.
The hypotenuse is what?
Oh.
15. And the other one is 9. So if I'm going to plug it into that formula, what do I have to think? If we're finding area, I have to have a
Base.
what do I have to have for area? Always, any shape.
Right angle.
A right angle. Do I have a right angle? Yes, I have a right angle right here. That means I need to use this side and
You add them together to subtract it by 36.
well, can I do Pythagorean theorem?
Yeah, that's what I did.
Yeah.
But that would take longer.
So x squared plus 9 squared equals 15 squared. Right?
Yes.
81, 225, subtract them. That's 144. Square root is 12. Oh, but what did you say you did instead?
Add those together and subtract them.
You can always do that?
When they give you that information,
Oh, when they give you the perimeter, what does perimeter mean?
The total.
the total
So
around
if I add all 3 sides up together, then it has to give me 36. Well, one of my sides is 9 and the other side is 15, which is 24 together, right? So if I subtract 24 from both sides, that tells me that my missing side, x,
12.
is 12. Do I really care which way you work it?
No.
No, I don't care at all. I want you to know that most of the problems we're about to get into have many ways to work it, which is why you need to show me your work. Are you with me? Show me your setups. I need to know that right here you're going to use this to be a 12. I have to see this. Because if you tell me my answer was 305, and I'm like, no, that's not the answer, the next question I'm going to say is, well, how did you get that? And you're going to go, I don't know, I did it yesterday. I've slept since then, right? Good. Well, I never was inside your head, so I couldn't tell you where you got your number from either. Are you with me? So show me your setup so that I can help you. Because if you constantly miss one of the numbers, I can figure out, oh, it should have been a 12 right here, and you keep putting a 6 or whatever. Okay, I can figure that out really quick to tell you what you're missing. Okay, but to find that final answer, I can't. So what should my answer be then?
108.
54
Yes.
meters squared. Did you do 9 times 12? Divided by 2?
No, I didn't divide it.
Oh, that's divided by 2. That's okay. All right, flip it over to the back side. Okay? Okay, trapezoid. Look on your formula chart. Somebody tell me what is the shape and what is the formula. You're looking on your formula chart. A equals 1/2 B1. What is a B1?
Base 1.
Which ones are your bases?
The one at the top and
It is not the top and the bottom. Because I can absolutely take this shape and turn it. The 2 sides that are parallel. But I must have a what?
right angle.
Right angle. Very good. I have my right angle. So this is my height and this is my base. I will never use a slanted side like a hypotenuse for area. Okay? And then this is a rhombus. Somebody tell me, what do you remember about a rhombus? It's a crooked square, right? What do you know about a square?
All sides are equal.
Good, all sides are equal. What else can you tell me about that right here? It's a right angle. Aren't these all right angles? And if you remember about a rhombus, all these triangles are the same. Do you see all 4 triangles? They're all exactly the same. They have to be. Because this has to be the same. All the sides, right? Okay? So look on your formula chart and tell me what's the formula. Area of a rhombus.
Oh, A equals 1/2 of D1 times D2.
D1. What's D1?
See.
Oh, it's the diagonal. It goes from one endpoint across the middle of the shape to the other, right? So a diagonal goes all the way across the shape. Okay, I'm going to give you a second. I want you to look at 1 and 2. Okay, watching? What shape is it?
That's called quadrilateral.
It is a quadrilateral. How do you know it's a rhombus? All of the triangles are the same. Watch. This is a 20 and that's a 10, right? Is this a 20 and a 10? So if I did Pythagorean theorem, wouldn't these both be the same?
Yes.
And on the other side, don't I have a 20 and a 10 and a 20 and a 10?
Yes.
So these are going to be the same? I really don't care. I can find the area of each little triangle multiplied by 4, right? Okay, I could do that. That's fine. There's nothing wrong with it. Just show it to me. Show me how you did it. Or I can recognize that this is a rhombus, and I can do D1 times D2 divided by 2. My first diagonal would be how big?
40.
40. And my second diagonal would be how big? So 40 times 20 divided by 2
Would be 60.
would be 400 units squared. Right? Because 40 times 20 is 800. Divided by 2 would be 400. What about the next shape? It's a square, but they didn't give me the sides. Well, I could take a second to figure out what the sides are. Isn't a square a rhombus?
Yeah.
Isn't a square a rectangle? Isn't a square a parallelogram? So really, I could use any one of those formulas and find out the answer. So on this one, I could do diagonal 1, which would be 26, times diagonal 2, which would be 26, and divide by 2. What's 26 times 26 divided by 2?
338.
338 what?
Units squared.
Units squared. Now, just for giggles, I'm going to show this to you. If this is really a square, then that means this is a 45, 45, 90 triangle, right? So this is x, square root of 2, correct? So that means that this side is 13 square root of 2. Would you agree? Which means that this side is 13 square root of 2. So if I knew the formula that you were thinking of, it's 13 square root of 2 times 13 square root of 2. Well, 13 times 13 is 169. And then here, don't I have a pair? What happens when I have a pair?
It gets to go outside.
It gets to come outside and play. Well, what's 169 times 2?
338.
338. Okay? Do I want to do all that work, or would I rather just do this?
That. The blue word.
Okay, are you with me? Do you understand? So there's lots of different ways to work a lot of these problems. I'm going to give you a second. I want you to try 3 and 4. Okay, how many of you got that for number 3? Okay, that one was simple, right?
Yeah.
Okay, what about number 4? What makes number 4 ugly?
There's that little height out there.
Good, the height is on the outside. Y'all look, we've looked at problems like this before, where we had a circle, and I told you that this side was 10. Well, how big is this right here? 10, right? Does it matter whether it's on the outside or inside? No, so they tell me that this is 90 degrees. Well, if I make 90 degrees right here, wouldn't that also be 28? And then what do these little triangles right here mean? They're parallel. Those are my bases. Remember, the two sides that are parallel are my bases. So area equals 1/2, 12 plus 24, times 28. So what do you get if you plug it all in? What do you get?
Oh, 504.
504 units squared. Okay? Let's look at number 5. Oh, good. It's another trapezoid. What's one of my bases?
19.
19 and 35, right?
Yes.
What's my height?
10.
What?
Just went around.
What do you have to have in order to work area? Oh, do they have a right angle on there?
Oh.
Yes.
Can I make one?
Yes. See.
So if this is 19, how big is this? Okay? I'm sorry, I'm not done yet. If these two sides are the same, does that mean that these two angles are the same?
Yes.
So what do we know about these two pieces right here?
They're the same.
So if this is 19, what do I do to find those pieces? 35 minus 19 gives me what? 16 divided by 2 gives each of these 8. So what do I do to find the height?
Pythagorean theorem.
Pythagorean theorem. X squared plus h squared equals 10 squared.
Gotta go the rest two anyway.
Alright, so on this last one it says that the trapezoid, the area of the trapezoid, area equals 1/2 base 1 plus base 2 times the height. So here we have to have our 90 degrees, here's our bases. Oh, but wait a minute, we don't have this base. And this is my height, so it's 1/2. One of my bases is 3.5, the other base we don't have. And then my height is the 2.5. But it tells us up here in the problem that the area is 13.75. Now, so I need to solve it, and our goal is to find out what this other base is. So what I'm going to do from there is I need to get rid of this fraction. So if I multiply both sides by 2, that means that these cancel out. And this would give me 27.5, 3.5 plus x times 2.5. Again, I still need to get the x by itself, so this means multiply, so then I can divide both sides by 2.5. So those cancel out. And that's going to give me 11. And then from here, we're doing just like what we normally do. I need to get rid of the x. I'm going to subtract the 3.5 from both sides. So that leaves me that x is equal to 7.5. So this other shape right here, that other base is 7.5. Okay, last one. If I'm talking about a rhombus and it has a perimeter of 40, remember a rhombus is a crooked square where all the sides are equal. So 80 divided by 4 is 20. So each side is 20. It tells us also that one of the diagonals is 24. Okay, so remember this other diagonal is going to cut it in half, so these are going to be equal, so that means it's going to be 12 and 12. So I can do Pythagorean theorem to find this side right here. X squared plus 12 squared equals 20 squared. X squared plus 144 equals 400. Subtract the 144. So x squared equals 256. So the square root of 256 is 16. So that means this piece is 16, which means this one is 16. So if I'm trying to find the area, and that's 1/2 diagonal 1 times diagonal 2. So one of my diagonals was 24. And we just find the other diagonal is 16 twice. That would be 32. So the answer here would be 384 meters squared.